combining capacity of an element is called valency. The combining capacity is called valency. So, for example, 1 to 30 elements valency. How to find out? First of all, you can write this electron configuration. So, hydrogen, H means here hydrogen. Hydrogen atomic number 1. So, now you can write this atomic number 1. 1 electron, 1s1. The electron configuration is 1s1. Yes, how many electrons there? Only 1 electrons. That is the first you can write the shell. So the first shell is only K shell, here only 1 electrons. The valency of electrons hydrogen is, for example, 1 only. So this is the valency of hydrogen 1. Now next one, helium. Helium atomic number 2, number of electrons to atomic number equal to number of electrons, number of protons. Now electronic configuration 1s2. So that is 1s2 first shell also. How many electrons there? Here 2 electrons. Here 1 electron, here 1 electron, so it will be rotating. Here 2 electrons. The valency s orbital, only 1 orbital, is a 1 orbital maximum filling electron 2 in its opposite spin. So the completely filling, it will be stable. So that's why, so the valency of helium is 0. So it is also called the helium also inert gas or stable gas. So that's why the valency of inert gas, stable gas also valency 0. At the same time, that is S having only 1 orbital, the 2 electrons only is there. So these 2 electrons opposite will be filled, so it will be stable. That's why it is valency also 0. These 2 conditions, valency 0. So atomic number 3, lithium, electron configuration 1s2, 2s1. So first shell 1s2, second shell 2s1. So the lithium having 2 shells. First shell 2 electrons, last shell is 1 electron. First the valence is plus 1, 2 and 3. Okay, that's why you can write Li plus 1, Li plus 2, Li plus 2. Now you can write here beryllium, atomic number 4. So electron configuration 1s2, so second is 2s2. So that is the second shell 2 electrons and last shell 2 electrons. That is a beryllium is, that is a plus 2 also. Plus 1 to plus 2. So now next boron. Atomic number 5, electron configuration 1s2, 2s2 and 2p1. So the second shell is, so 3 electrons only. So s orbital 2, p orbital 1. Now in first shell and second shell, first shell 2 electrons, third shell 3 electrons. This is a valency shell, so that's why plus 1 to plus 3. So now you can write the valency of boron is plus 1 to plus 3. Now next one is carbon. The carbon is, that is the most important hydrocarbons, and it is electron configuration 1s2, 2s2, 2p2. So that is a second shell of this valency shell. In is first shell is carbon 2 electrons, first shell 2, second shell is 4 electrons. The valency of carbon is how much here? 4. So that's why the maximum higher valency of carbon is 4 only. So this is the carbon. Next nitrogen onwards, just will be different only. How like for example, the nitrogen to here fluorine is negative will come in. The balance is and the negative is there. So how it is, for example, negative, I can explain now. Nitrogen atomic number 7, symbol is N. Electron configuration 1s2, 2s2, 2p3. So s orbital only 1 orbital. So the p orbital 3 orbitals, they are px and py and pz. So s orbital 2 electrons will filling, p orbital each one orbital 1 electrons. Now completely filling needed of 3 electrons. That's why px orbital 1, py 1, pz 1. So totally 3 electrons only needed. The valency of this nitrogen is -3. So that's why you can write this n minus 3 you can write. The valency of nitrogen, the n power minus 3 can write. So because it is the valency of nitrogen, the p orbitals, 3 electrons needed are gaining of electron getting charge minus. So that's why the valency of nitrogen is minus 3. So now next one is important, is oxygen also is. The oxygen atomic number 8, the electron configuration 1s2, 2s2, 2p, 4. The first shell and second shell. First shell is 2 electrons, second shell 6 electrons, s orbital and p orbitals. And s orbital 2 electrons, px orbital 2 electrons, and py 1 electron, pz also 1 electron. So fulfill needed of this oxygen is py 1 electron, pz 1 electron needed. We will be gaining 2 electrons. So that's valency of oxygen is minus 2. So that's why you can write O minus 2 you can write. So this is the O minus 2 means here gaining 2 electrons. That only meaning of this O oxygen. Now last one is fluorine. Atomic number fluorine. So that you can write, for example, electron configuration 1s2, 2s2, 2p5. So first shell, second shell. So this 2 comma 7 you can write. So first shell, second shell. S orbital only 1 orbital 2 electrons. P orbital 3, px, py, pz. So here px 2 electrons, py 2 electrons, pz 1. So completely filling needed 1 electron. That's why fluorine is minus 1. So you can write F minus 1. So this is the fluorine. Now last one is a gas. Neon is a net gas. That is a full fill configuration 1s2, 2s2, 2p6. So first shell and second shell 2 comma 8. So 2 comma 8 means is first shell 2, second shell 8 electrons, and the total is completely filling. Is S orbital completely filling, and p orbitals 3 orbitals also completely filling. So fill valency is full fill. Px, py, pz orbital electrons completely filling. It will be stable. So that's why there is no gaining and lossing. So the valency of neon is 0. So that is one condition. Second condition is neon inert gases or noble gases valence is completely filling. It will be more stable. So the valency of neon is 0. So that is all. Not only this, and inert gases helium, neon, argon, krypton, xenon, radon. These all are is valency is ns2 np6. ns2 np6 means it will be completely filling s orbital and p orbitals. So this inert gases completely will be valency 0. So it is also important. Okay. So this is the some examples of 1 to 10 elements valency. So what about the valency means the combining capacity of an element is called what? The valency. Okay.